Hello everyone, good morning. So it's another day and another lesson for the origin of the Earth. So last meeting we have finished discussing the origin of the Earth's continents or the terrestrial environment. So consequently, combination with that, we also have to discuss the origin of the Earth's ocean, and that will be our topic for today. However, before we go to the formation of the ocean, we have to first understand how or what are the environmental conditions that leads for liquid water to be able to accumulate on the terrestrial basin of our world. And before ocean discussion, we'll be first discussing the atmosphere. Okay, so let's have a correction of our, again, no, I would just like to emphasize last meeting, correction on the idea of the first supercontinent. No, we have thought that Rodinia was the first supercontinent. However, research has shown that Rodinia is thought to only assembled 1.1 billion years ago. Before that, 1.8 billion years, there is now your supercontinent known as Nuna or Columbia. Okay? And at 2.5 billion years ago, before Nuna and Columbia, you have your Kinorland. And earlier than Kinorland, there's another supercontinent, and this is now your Ur, which is said to be 3 billion years old. So if you can understand this, as we have repeated, because of several geologic processes within the Earth, because of the decay of the radioactive material on our Earth's core, it reflects now the convection cells on your mesosphere and asthenosphere. It now makes sure, or it now causes our lithospheric plates to move around. So since we only have one Earth, there's a time billions years ago that it moved away from each other and they meet on the other side of the Earth, probably. Now, on our time right now, on our geologic time right now, our crustal plates, no, our oceanic crust and your crustal plates now are moving apart from each other. So technically, billions of years from now, probably these crystal plates will meet on the other side of the Earth. Probably that's what is happening right now. Now, for a recap, no, we have talked about the Big Bang Theory. So we have talked about the planetary formation, the formation of your protostars, to your stars, your galaxies, and so on, up to the present of the geologic activity of your Earth. We have talked about nucleosynthesis. This is the one where we talk about in the Big Bang Theory. Because of pressure and intense temperature, no, the pressure, there's now accretion between your molecules, your elements, no, and even your subatomic particles, forming now several elements. Elements form molecules, molecules, and so on and so forth. So we have there the formation of your helium and of that of your hydrogen and the rest of the elements. Now, let's look at the early Earth. Your early Earth, way back before that we have talked about, it is formed via the accretion of your grains and dust and gases. We have talked about last meeting about what we called about the iron catastrophe that happened. So there were now formation of some of the elements, no? The proto-earth was molten dense material that's contained of nickel and iron that flowed to the center, the iron catastrophe. The lighter materials now, the silicates, no, the manganese, the silicon now flows on top of that. So, ito na yung tinatawag natin ng iron catastrophe. And consequently, the earth now cools and solidifies into the separate, no, chemical layers of the earth. Now, the overall density of the earth, this is for your understanding, no, way back before is 5.5 grams per cubic centimeter. So the earth has a lot of trapped gases in its interior. And this is the one that is undergoing decay, the radioactive decay. These trapped gases, not only gases, no, but there are several elements in there that are in the form of their isotopes. And these isotopes could break upon, no? Pwede silang mag-break and will release energy or heat in its environment. And this is where now what drives our convection cells. And you know, last meeting or last on our video, that these convection cells now could affect our lithospheric plates by the different plate boundaries. So you have their divergent, convergent, and transform. Now, again, no, let's emphasize that before, the Earth has more volcanic activity when compared right now. Because of this iron catastrophe, because of the decay of the radioactivity, there's a lot, no? Ang daming kailangan i-release na trapped gases and trapped energy. And this is why the early Earth contains a lot of volcanic activity, no? So volcanic activity now is caused by the heat within. This is caused by the radioactivity. Now, this radioactive decay causes now for a lot of volcanic outgassing. So volcanic outgassing means there's a lot of things being thrown out in the early surrounding of your planet Earth. Now, bakit ko to dinidiscuss, ma'am? At dinidiscuss mo na naman yan, no? Tapos na natin yan. Let me give you an idea how the Earth's ocean was formed. Earth's ocean was formed because there's an intermediate that causes Earth to cool down, cool enough to let liquid water to stay in liquid form. And that intermediate is product of this volcanic outgassing. So ano ba yun? Give me time and I will explain everything to you. Make sure to remember your volcanic outgassing. For us to understand how oceans came to be, there is a need for the atmosphere to form first. And this is what the intermediate thing that I am talking about to you. Now, atmosphere was formed for about 4.1 or 4 billion years ago. Early atmosphere was likely derived from volcanic outgassing. This is why I am emphasizing earlier the iron catastrophe, the radioactive decay, the continuous volcanic activity, because I want to emphasize that volcanic activity resulted to a much of volcanic outgases. And this volcanic outgases contain several chemicals, no? Volcanic outgassing, for you to have an idea of what I am talking about, you look into this. This is what we call as your volcanic outgassing here. No? So you can see in here, there's a lot of smoke, dust particles, several chemicals being outgassed or thrown, no, in the atmosphere. This is volcanic outgassing. Most commonly, your volcanic outgassing releases your volatile water or your water vapor, your carbon dioxide, carbon monoxide, you have hydrides, you have nitrides, you have your dinitrogen, no? You have dihydrogen, you have your HCl, you have there your sulfides, sulfates, sulfides, no? You have there your chlorides, you have there your amides, methane, you have sulfides or disulfides, and a lot more. What does this entail? No, bakit kailangan natin maintindihan ito? For now, what I want you to understand is volcanic activity causes volcanic outgassing. And volcanic outgassing will release a lot of elements. And these elements could be in dust form, vapor form, or small elements that could not be seen by the naked eye. They were thrown on the primitive surrounding of the Earth. We cannot say that there is an atmosphere before, no, yung 4.5 billion years ago, kasi wala, because of the intense temperature or volcanic activity, because of intense sunlight and a lot of things, 500 million years, wala pang nakikita o walang atmosphere talaga. But because of the siguro sabihin natin na dahang-dahang pagbaba ng temperature or dahan-dahang paglamig ng primitive Earth. Let me just use my camera. Okay? There. No? Dahan-dahang paglamig ng primitive Earth, it now entails o medyo napapa-cool down na nito ang kanyang paligid enough for these outgases to be circling around the primitive surroundings of the Earth. Hindi ko siya magamit na atmosphere kasi wala pa tayong atmosphere here. Now, trace amounts of free oxygen can be seen, no, konti, but more of it is absent. No? Although oxygen was combined with other compounds like your carbon dioxide, carbon monoxide, water vapor, your sulfides, or sulfates, hindi pa rin naman siya free, as in free oxygen as it is. There is an oxygen, yun sinasabi ko, but there is no free oxygen yet. Now, so, sorry, natakpan ng aking mukha, no? But then again, this volcanic outgases, ito ang karaniwan na nakikita natin or can be observed even up to the moment when there are eruptions of volcanoes. Now, ano na naman ngayon kung meron kang volcanic outgases? Ano naman ngayon kung meron ka nitong mga chlorides na yan, yung mga disulfides na yan? So what, ma'am? No? Those will now combine together and will cause for it to be forming aerosol. No? Itong aerosol natin. So as you can see in here, if there is a volcanic outgassing or there's a volcanic activity, number one, what happens is that, of course, there's an eruption, no? But there is volcanic outgassing here. Now, this volcanic outgases, o itong mga elements na nilabas ngayon ng volcano mo, will now percolate, no? O parang kakalat siya on the surrounding of the Earth. So, kakalat yung mga sulfides mo, and they could get together with your water vapor now, forming now your sulfuric acid, your hydrochloric acid could be maging H2Cl or and so on. So maging chloric acid siya. You can have now several chemical formations. Why? Because of the action of your UV light, yung tinatawag nating photolysis, no, or photolysis, no? It will lyse some of these elements or these molecules, and because it lyes o pinaghiwalay niya, it is now free from each other. They could now combine with other to become more stable. The thing is, the more that there is volcanic activity, sige, erupt ng erupt, sabog ng sabog during the early or primitive time, mas marami ka ngayong nilalabas na mga chemical elements on the surrounding or outside of your Earth. Now, this could be continuous and continuous since sabi nga natin, no, early Earth, very high ang volcanic activity. Kung mataas ang volcanic activity, of course, marami kang volcanic outgases. Ano naman ngayon kung marami tayong volcanic outgases? This will now causes for an increased planetary albedo. I want you to highlight this, itong albedo na ito, no? Ano ba yung albedo na yan? Albedo, this is the capability or the measure of how much you could reflect something back. That's albedo. How much of light could be reflected back. Now, ito yan ha. If you have a lot of volcanic outgases, a lot of chemicals, makikita nyo itong parang snow na to. Can you see this? Itong parang tuldok-tuldok na snow na to. These are now your volcanic outgases. Now, if there is sunlight, no, kapag merong sunlight na papasok ngayon dyan, o tatama dito, no, as you can see here, na given itong arrow na to, pag ito tumama dito, no, what happens is that there will now be deflection back to your outer space of your sunlight. This is what you call as albedo. Albedo, again, no, it's a measure of how much photons or how much UV light is being reflected back by something, by an element, or by a molecule present on the area. So the more, again, no, the more that there is eruption, the more volcanic outgases you have, the more elements now are circulating or percolating on the outside of the earth, the more now becomes, this now becomes your aerosol na tinatawag natin. Itong mga aerosol ngayon, dyan, will increase the planetary albedo. What do we mean? Dahil may present kang mga aerosol dyan, yung tatamang sunlight ngayon dyan, some of it will be reflected back. Yung iba nakakalusot sa kanina, but much of it will reflected outside the atmosphere. This is the difference nung unang-una pa lang, no? Mainit na mainit ang earth natin because direct ang sunlight, wala pang mga masyadong volcanic outgases nung binubuo pa lang o nagkakaroon pa na tayo ng iron catastrophe. But once the layers of the earth are settled and there is now the product of the iron catastrophe, sumasabog ngayon yung mga volcanic eruptions natin. Sumasabog ngayon yung mga volcanoes natin. And that eruptions now will lead to the release of these outgases. These outgases becomes now your aerosol. Kasi nabubuo sila, nagsasama-sama sila because of photosynthesis. Now, ano ngayon kung marami tayong aerosol dyan? The more aerosol we have, they now become spread on the surface of your planet Earth. No? Marami kang aerosol ngayon, it will now causes for some of the photons o yung mga tumatamang waves ng UV mo dyan to be reflected back to the atmosphere. So, ano ngayon? If there is now, because of these aerosols here, no, itong mga tuldok-tuldok na yan, because of these aerosols here, this will now cause for increased planetary albedo or reflection. Kung mataas ngayon, kung marami ka ngayon na re-reflect back on the atmosphere, what happens now is that there is now a cooling effect o lumalamig, bumababa ang temperatura sa baba o sa iyong early atmosphere. Okay, para mas maintindihan natin ito in a more, paano yan? Hindi ko pa rin nagigets. Okay, let's take a look at Mount Pinatubo, no? Mount Pinatubo, its eruption here in our place way back before causes an increased planetary albedo in the world, no? Yung pagsabog mismo ni Pinatubo, hindi lang dito actually in the Philippines ang effect niya or dito sa ating province ang effect niya, but it affected worldwide scheme. Ayun, sabi mo, talaga ba, ma'am? Let's look at this, no? Now, let's have this, no? Pinatubo volcano or the eruption of Mount Pinatubo injected about 15 million tons. Again, i-highlight ko, it injected, no? Nag-release siya ng 15 million tons, tonelada, milyong tonelada, sobrang dami ng sulfur dioxide into the atmosphere. Not only that, it also given a lot of some of the outgases, no? Hindi lang naman sulfur dioxide ang nire-release kapag nagkakaroon tayo ng eruption. Now, this 15 million tons of sulfur dioxide now was injected to your stratosphere or in our stratosphere, where it reacted with water to form a hazy layer of aerosol particles. Ayan na naman siya. Balikan natin yung kanina, no? Eruption, aerosol formation causes for increased albedo. Albedo, this is the measurement ng pag-reflect back ng mga photons or UV outside the atmosphere, and that will now cause for a decrease in temperature. Now, si Pinatubo, isa lang to ha, isang volcano at isang eruption. Ganito kadami na agad ang kanyang outgas o ni-release. This forms now a layer of aerosol particles. Now, over the course of 2 years, within the 2 years period, there was a strong stratospheric winds, which now causes for the aerosol here, yung mga aerosols dito sa ating lugar, to be spread worldwide, across the globe. So imagine, isang bulkan lang ito, panahon pa natin to, isang bulkan siya, ganun na ka-release agad. In 2 years time, naikot niya yung aerosol o yung mga molecules, yung mga dust particles na yun, naikalat siya sa buong mundo within 2 years. And that's how much it was released. Isang bulkan. Now, look at this, no? This pictures in here. So, accordingly, before the eruption niya, no? Before its eruption, you can see in here na malinis naman. Blue here, no? Ito. Ay, hindi ata nakita. This one, no? Ito yung sinasabi ko. Before its eruption, blue ang ating stratosphere, malinis. Mababa ang ating mga aerosol, mababa ang ating mga elements circulating around the atmosphere. However, upon its eruption, you can see now that there is now a coloring, no? Nagkakaroon na tayo ng coloring dyan sa mga lugar na yan. Up until now, the pagkasabog niya, no, nagkakaroon kayong coloration dito. May nakita kayong parang red, yellow, and something like that, and so on. So, tingnan natin ang mga dates, no? Na, sumunod, ikatlo, this one, August to September, and then we have there on your December. So, the Pinatubo eruption, no, increased aerosol optical depth in the stratosphere by a factor 200 times, no? And it covers the world for almost 15 months. Now, ano ang consequence na? The consequence in here is that the average temperature around the world dropped by 1 degree Fahrenheit or 0.6 degrees Celsius. Maliit, mababa lang naman pala, ma'am. No, sasabihin nyo, mababa lang naman pala, ma'am. Maliit, yes. However, no, according to this research, the eruption of Mount Pinatubo in our place causes for 3 years delayed in the climate change. Yung pagsabog niya actually, nag-cause daw ng overall na 3 years, 2 to 3 years delay ng climate change or increase in temperature level. Rather, the presence of this aerosol or these outgases causes for the global temperature to drop by 1 degree Fahrenheit. The same time, it delays, no, global warming. Hindi pala climate change. I'm so sorry. It delays 2 to 3 years ng global warming. That's just one volcano. Imagine the effect now on the primitive Earth, where there are multiples of volcanoes erupting, multiples of volcanoes outgassing. Diba? Kung sa isa, ang laki na ng effect niya globally, 1 degree Fahrenheit, how much more during the primitive Earth or primitive environment of our early Earth, diba? Pinag-usapan natin dyan, ang daming-daming volcang sumasabog. So, in 100, no? In 100 volcanoes that could erupt nang simultaneously, it could drop around 100 degree Fahrenheit of the global temperature from a very, very hell type or hellish type na environment. It slowly now drops the temperature of our primitive Earth. Kung maraming bulkan ang sumasabog, marami nga namang bulkan sumasabog during this primitive time. Kung itong Mount Pinatubo, isa lang siya, it drops the global temperature by 1 degree Fahrenheit, it delays global warming by 3 years, how much more 100, 200 to thousands of volcanoes erupting simultaneously on the primitive Earth. So, with this understanding, no, this volcanic outgases na to continues for billions of years, from 4.5 billion to 4 billion years. Imagine how much outgases was released in the surface of the primitive Earth. Para ko sumasayaw. Sorry na. Okay? Now, look at also the components, no? Yung prebiotic atmosphere natin, it's said to be dinitride, no? May mga dihydride, may mga ammonia tayo hydrogen, more amides, we have, and now look at our modern atmosphere. Of course, it takes billions of years for us to arrive in this form or in this chemical content of our atmosphere. But what is, no? What is the, excuse me, the good side of this continuous volcanic eruption on the primitive Earth is that you are now giving rise to your primitive thin atmosphere. If you can see in here, this is artistic, ano po mga anak, artistic lang siya. If you can see this one, no? Hindi siya makita. Ano yung kulay? Red? I don't know. White? Let's try white. Try natin ang color white. Okay. This part, hindi pa rin nakita. Okay, blue. Yon. This portion in here, nakikita niyo ang kulay blue na yan, na parang ginagawa kong asterisk here. Kung makita niyo siya, no, parang siyang brownish na may holes in here. This is our primitive Earth before. Your primitive Earth before is just a product of your volcanic outgassing. Kaya, therefore, yung kanyang chemical component is, well, para sa mga katulad natin right now, no, is very nauseous, very toxic pa siya. No? Kasi nga, ang component niya noon are these components or these chemicals that were brought by your volcanic eruptions or outgassing. But the thing is, no, it now paves way, no, yung volcanic outgassing na yan, yung volcanic activity na yan ng Earth, paves now the way for the cooling of the surface of the Earth, having thin but toxic atmosphere. It's okay. Walang problema. Wala pa naman tayong organism in here. But one thing is for sure, lumalamig because of this presence of this thin, slow production of this thin atmosphere. The entire global temperature now slowly gets cool. No? Lumalamig na siya. Now, because of that, no, due to this volcanic outgassing, large amounts of aerosol were released upward, which in turn reflects about 60% of the UV light, no, and now resulted into the entire planet, or what we call as your planetary cooling. And because your planet now starts to cool, it can now, no, store your liquid water. So, due to planetary cooling, condensation, and precipitation of acid rain pa mga anak, no? Kasi nga, ang primitive thin atmosphere natin is made up of outgases. So, more on acidic pa talaga. So, but because of that planetary cooling, there's now the condensation and precipitation of acid rain. So, however, initial precipitation, of course, nagve-vaporize pa siya upon hitting the ground on the first, no? Yung mga 4 billion years ago, kasi mainit-init pa naman talaga ang lupa. However, one thing is good, no? One thing is good. Because of this outgases, nagkaroon na tayo ng albedo, increased planetary albedo. The increased planetary albedo now will now cause for an increased planetary cooling. So, habang tumatagal, lumalamig na ngayon ang Earth. Hindi naman in a snap of time like that, malamig na yung lupa mo. Because, again, as you can see here on the picture, no? Dito sa picture na to, hindi na makita. Sorry. Dito sa picture na to, hindi pa rin makita. Ano ba yan? Green. Let's try green. Ayaw. Sorry na. Pero sige, ganito na lang. Dito sa part na yan, nakikita nyo may mga lava pa. Diba? And that lava in there, no, mainit pa talaga. So, hindi pa kayang maging liquid water na water. But the thing is, there is now raining. There is now precipitation that happens. Okay. This continues for millions of years until finally, by 3.8 to 3.6 billion years, no? So, from 4, kasi sabi 4 billion years daw nabuo ang atmosphere. Siguro mga 200,000 years after, mga ganyan, or 400,000 years after nung meron na tayong manipis na atmosphere, water now gets collected into warm seas and ocean above our crystal or our crystal plates. So, it takes that much of time. Tapos, di ba, parang binabaliwala lang halos lahat yung atmosphere and ocean natin. Imagine how much it needs to form that. Tapos, pinupollute lang natin, di ba? Sakit. Okay. Now, let's now go on to how oceans, this magnificent body of water now, gets formed. Of course, ngayon, dahil meron ka ng unti-unting pag-iipon ng tubig, ayan na. Pwede nang nakawin ni, ano ba to? Si Maui ng Moana, ang jewel ni Nerfiti, parang ganyan. Kidding aside. But, before we go to this portion or this status of being a planet with a lot of water, tingnan natin paano siya nabuo. And how does life also started? Because according to some of the researchers, life started on the ocean. So, bago natin makita ang buhay at magkaroon ng evolution, buuin muna natin ang karagatan. Now, origin of our ocean. There are two theories on ocean's formation. One, Earth was formed with water within, and that this came from inside out. So, meron tayong mga theory na yung water molecule natin o yung mga tubig na meron tayo, most of it come really from the inside to sa layers of earth natin and were brought outside. So, via volcanic eruption or some of it is yung mga terrestrial activities na re-release daw yung mga elements for the formation of water. No? Ayan siya. So, nare-release daw yung water vapor, no? Nakita nyo dyan, from volcanic outgassing, the hydrogen, the oxygen, no? Nare-release daw, which could give rise now to your water, as one of the theories says. However, there's another theory that Earth was a dry planet and water was brought in by other sources, such as your meteors and comets that are constantly bombarding the primitive Earth. Now, if you will ask, saan po sila kanilang dalawa talaga, ma'am? Let's look at some of the evidence. Okay? So, sources of ocean water, there are basically three possible sources of water in the primitive Earth. One, there is separated out from the rocks that make up bulk of the Earth. No? Isa yan sa theory. Two, there's arrived as a part of the late accreting veneer of water-rich meteorites, no? Similar to your carbonaceous chondrites. Nabanggit ko na to last meeting. Itong mga carbonaceous chondrites natin. Ito yung evidence ng panspermia or cosmic theory. Kung maalala niyo yung electron microscope that we have shown na merong microorganism. At the same time, yung ganong chondrite o yung ganon, it carries also water-rich minerals or water vapor, or no, not water vapor. I mean, water molecules on the rock forms. No? Pwedeng galing daw sa iba. Or, it comes from your comets. So, we have three sources. But we have two major, within and your outside. Yung outside mo, dalawa. Meteorites, meteors, and your comets. No? So, accordingly, there is, kung outside siya, no, if it came from outside our planet, no, there are several studies saying that yung mga carbonaceous chondrites, no, in the form of our meteorites or meteors or asteroids, no, carry this water molecule. And accordingly, di ba, kung pakikinggan po natin yung Big Bang Theory, again, pwede, there's a high chance that these water molecules or elements accreted, no, and form in there. So, pwedeng ito ngayon, tatama yan sa protoplanet mo, madadala siya. Pwedeng yung ating mga comets din that move, no? Ang alam niyo naman ang comets, because the tail, no, yung nakikita nating tail sa mga bulalakaw ba? O mga comets natin, yung shooting stars natin, are actually the vaporization of the solid ice particles that is now formed on that rock material. No? Yun yung mga sa Halley's Comet, yan yung mga yun. And yung kanyang pag-ikot daw sa proto-earth natin and pagtama niya could also bring water within. The same with your meteorites. So there are a lot of sources or provenance for the Earth's for the Earth's water sources. So, within and outside yan. So, meron tayo. Now, so continuous impact. Again, this is an artistic, artistic point of view or parang drawing lang of what could have happened. So, pwedeng within the Earth, there is another release. Kaya nagkakaroon tayo ng pakonti-konting formation ng, hindi makita, pakonti-konting formation ng water in here, mga small pools lang siya, no? And then, pwedeng dinadala din daw yan ng comets, no? Kapag ito ay bumibisita sa ating mundo, o kapag merong impact ng mga meteors. So, pwedeng within, and pwedeng outside ang sources. So, this continued, and continued, and continued, no? And continued, no? Pwedeng nag-continue, until such time that because there is a planetary cooling, there's the atmosphere, continuous buildup of your atmosphere, there is now the, ayan na, nabubuo na yung liquid water natin on top of our terrestrial plates. But there again, no, continuous pa rin yung outgases na meron tayo here, continuous pa rin ang volcanic eruption. However, no, because lumamig na, may atmosphere ka na, umuulan, no? Yung component ng ating primitive Earth are still, hindi pa rin siya yung component na meron tayo. Still, no? Medyo toxic pa rin yung component niya. You still have dihydride, helium, you still have your methane, ammonia, no? Medyo toxic portion pa siya. Kasi nga, kahit na meron tayong formation ng clouds in here o umuulan, no? It starts raining like that. Pero ang rain mo, still acid rain. So, because meron ka pa rin continuous volcanic out gases. Hindi pa siya sink-friendly ng most of the rains that we do experience right now. And this now, because there is now, no, sabi niya, because there's now your liquid water or your ocean, no, and there are now some of your inorganic elements being stored or binababa dito sa ocean. This could now lead, no, mababalikan natin yung sa sinasabi ni Oparin and Haldane hypothesis and even Miller-Urey on the formation of the organic monomers, no? Itong organic monomers natin na to, from these mga inorganic molecules of the Earth from the atmosphere. So, ayan. Purahin ko lang sandali. No? Ayan. Okay. Now, again, nagkakaroon tayo ng deposition or precipitation of inorganic molecules. As you can see in here. Gawin natin kulay green para mas kita. Ayan lang po ha. Let's make it in a green form para makita. Okay. Ay, sorry. Now, because of the precipitation, no, yan, pag-ulan, continuous sa pag-ulan ng yan, it releases now methane, water, carbon dioxide, hydrogen cyanide, mga ganyan-ganyan sa ating primitive ocean. So, there are a lot of inorganic molecules on our Earth, as said by the itong Oparin-Haldane hypothesis na to, and these inorganic molecules daw could accrete together, come together to form now your organic monomers. These organic monomers, which is your amino acid, your sucrose, glucose, no, yung mga yan, or yung mga fatty acids mo, could give rise now to your organic polymers. Your organic polymers na, mas malalaki na yan. So, yan yung ating mga biomolecules. Kumbaga, What Operlin-Haldane hypothesis is suggesting on the abiogenesis molecular theory na ito, no, palikan natin, itong mga outgases na to, no, na precipitate sa ocean now gets, no, reacted together, forming now itong ating mga organic monomers and polymers. So, ito yung sinasabi ni Oparin and Haldane. There is now, because of sunlight, no, because of your lightning, and because of the heat coming from the volcanic eruption, this now, itong mga methylene natin, dicarbon natin, water, yung mga inorganic molecules gets now accreted or nagre-react sila together, forming now a more organic monomers. So that happens spontaneously. This was tried, no? Again, sinabi ko nga, sinubukan ito sa Miller-Urey experiment through laboratory simulations, no? Sa Miller-Urey experiment, it was proven. Sa iba, it was not. But lately, no, sinasabi na meron ding, if week to week, meron na konting tweak na gagawin, makakapag-produce pa rin talaga ng organic monomers. However, no, sabi nga nung isa nang sumubok sa Miller, hindi totoo yan. What is missing in here is that you cannot make or assure na makakabuo ka ng organic monomers. So, marami pang researches na ginawa. One of which is that suggesting the primordial soup of life. Ano nga ulit ito? According to this primordial soup of life, there is now it describes, no, the aqueous solution of organic compounds that accumulated in primitive water bodies of early Earth as a result of endogenous abiotic synthesis and the extraterrestrial delivery of comets, meteors, and so on. No? However, no, one thing na hindi na i-emphasize is that saan ba talaga ang birthplace ng buhay sa Earth? Is it really the ocean or another area that's more, sabihin natin, kapani-paniwala? Accordingly, no, hindi natin pwede sabihin na walang effect yung ocean sa birth of life on Earth. Excuse me. Actually, it aids, no? Tumulong siya sa pagkakaroon ng buhay sa Earth. Kaya lang, ang pinaka-birthplace, kasi yun yung parang sinisita sa Oparin-Haldane and Miller-Urey experiment, saan talaga? Parang hindi naman pwede na sa tubig mabuo itong mga monomers na to. Kaya, yun yung sita doon sa theory na yon. Kaya some of the scientists now have proposed that it is actually the clay environment beneath our ocean as to the birthplace of life on Earth. Now, tingnan natin kung totoo ito, no? In the primitive Earth, no, it was said that yung upper portion or the above ground, no, makikita nyo dito, hindi ko naman nataas ang kamay ko, on the above ground, no, sa taas, here, dyan sa taas natin, it is highly oxidizing. So, what do we mean by oxidizing? Leo the lion said, girl, diba? Loss of electron, no, is oxidizing. Loss of electron. Leo the lion said, girl. No, girl, gain of electrons, reduction or reducting. So, yung taas natin, the above ground of the primitive Earth is said to be highly oxidizing, and the within or beneath the ground of the Earth, it is highly reducting. The presence of oxidizing ocean and reducting clay actually daw causes yung alternate movement ng mga molecules natin from oxidizing sa ocean sa taas to reducting sa ilalim sa clay, then babalik siya on oxidizing sa taas, then reducting na naman sa clay, then oxidizing, reducting, oxidizing, reducting. This process daw actually, no, manifested and make the formation of your biomolecules successful rather than just pertaining to the ocean as Operin, Haldane, and Miller-Urey experiment. So tingnan natin. Now, according to some of the studies, if we have this one, hindi ko alam kung makikita, this upper portion here, this is your clay sheet. Hindi ko kayo minumura, ha? Hindi ko kayo minumura mga clay sheet yan. And then we have another clay sheet beneath, And then, microscopically, there is now a certain layer o parang space between your clay molecules or clay sheet. You know for a fact about this, how clay soils behave and how do they retain water, because of the closed spaces na meron siya. Itong spaces na to, accordingly becomes now your RNA breeding grounds, or not only RNA but also other monomers. It becomes now breeding grounds for your elements or for your biomolecules. Why? Remember, yung ilalim, highly reducting. So, ano ulit ang reducting? They gain electrons. So, how do they gain electrons? They form bonds between each other. So, magbabond sila yan, hahaba siya ng hahaba until such time it becomes now overturned o ililipat akit, mangyaangat na naman siya on the above ground kung saan there's now losing of electrons, again, oxidizing, pwede ngayon siyang maghiwa-hiwalay. And because of this process of pagtaas niya, nag-lose siya, nare-reform siya, and then babalik na naman siya sa K, and then madudugtungan na naman siya, magre-reform na naman siya. This process actually daw, because of siguro, ang tawag mo dito, trial and error, it now releases the formation of several chemicals or molecules. So here, yung dito within in here, nagkakaroon ka ngayon ng building up of molecules, building up of your biomolecules from inorganic molecules because of the presence of this clay in here. Highly oxidizing gaining of electrons. Okay. Okay. So, let's look at this, This is, again, so sinasabi ko sa inyo kanina, this is the clay sheath on top, and then clay sheath at the bottom. So, your clay under the earth is very reducting. So, there's gaining of electrons. And because very manipis yan o napakalit ng space nan, it now causes some of this inorganic molecules, itong kulay blue na to get attracted to each other. Kasi maliit ang space, maaaring there's a chance that mafo-force sila ngayon to be near each other. And because of that, again, these are elements and they contain charges. These charges now could cause hydrogen bonding. Lalo na kung sa mga hydrogen elements. Alam niyo to, in your chemistry, you have there your hydrogen bonding, covalent bonding, and ionic bonding. These bonds now will ensure the strength ng pagkakadugtong ng mga inorganic molecules mo, forming your biomolecules. So, this is how, or most of the researchers now are talking about. Walang problema sa sinabi ni Operin and Haldane at sinabi ni Miller-Urey. It actually causes for some of inorganic molecules to bond together on a very oxidizing ocean. But because nagpe-percolate sa ilalim ang tubig galing sa ocean, from oxidizing top, pupunta siya sa reducting, nagkakaroon ngayon sila ng attraction to each other. Nag-gain ngayon sila ng electrons, nagbabond sila ngayon, nagdudugtong-dugtong-dugtong sila ngayon within or underneath clay. And then, lalabas na naman siya, and dito, pwedeng magkaroon ng loss of electrons because it's very oxidizing. Mare-restructure na naman yung mga molecules. Until such time that there is a continuous oxidizing, reducting, oxidizing, reducting, oxidizing, reducting, And then, no, continuous interaction of the materials now causes for a more complex biomolecules. Hindi na lang siya basta yung sinasabi ngayon on the primordial soup of life na ganun lang siya, nasa ocean lang siya. No, there is now the play up of oxidation, reduction on the changes or yung movement of these molecules from above ground to the lower ground and vice versa. Paulit-ulit siya ngayon. So, nagiging mas complex yung biomolecules. Now, from this very simple monomer, continuous oxidation, reduction, pagpalit-palit niya sa ocean clay environment, this now leads to a formation of a lot of monomers. These monomers could have attracted each other to form now polymers. Or magkakaroon na tayong tinatawag natin na polymerization. Pagdami na ngayon ng mga monomers mo. Okay? Yung mono mo, yung polymers mo ngayon, ganun din, umiikot pa rin siya. Oxidation, reduction, until, no? For example, kung fatty acid ito, there is now the formation from here. No? Pwede na ngayon siya magkaroon ng film-like. Kung fatty acid siya, yung magbibigay, give rise to your cellular membrane na merong hydrophobic head and hydrophilic tail. Hydrophilic head and hydrophobic tails. Now, magkakaroon ngayon siya. Pag pumunta siya sa ocean, magna-line up ngayon siya kung saan nakalabas yung nakalabas yung hydrophilic part at nakatago yung hydrophobic part. Then, this now, no, kapag yung ganun, magkakaroon ka ng cell membrane, itong amino acids mo will form, no, magbubuo yan into primary, no, amino acids, no, mga primary yan, konting-konting mga peptides yan, and then they become now yung nasa beta sheets na siya, may mga folds na, may mga tupi-tupi nang nangyayari sa ano mo, sa protein mo until it becomes a tertiary one o malaking protein na siya. So from amino acid, it will now give rise to your specific protein. Your protein could be ribose, could be like your sa formation ng ating part ng ating mga protein, mga enzymes, ayan, nabubuo na siya. No? Now, yung kanina na fatty acid now, no, yung may mga hydrophilic heads and hydrophobic tails could now enclose some of this monomer. Paunti-unti, nakakapasok sila dyan. Ayan na siya. There's now your heads in there, yung mga globules na yan, no? Yung ating mga hydro-loving, water-loving, part. Tapos yung ating mga takot sa tubig. Nag-i-enclose niya ngayon, na-enclose niya yung mga ibang mga monomers. And this could now, no? Within that, pwede rin na mabuo ngayon yung ating from unstable RNA, nagkakaroon ngayon tayo ng DNA, no? Papasok din siya dun sa nabubuong cellular membrane. So, continuous ang cycle, no? May mga lipids, proteins, pumapasok siya na ayos until such time, no? This could result now to your first cell, the micelle. Now, your micelle could have made several functioning, no? And more consequently, through the years, kumanta, from that of the cells na dati, yung nag-enclosed pa lang siya, nabuo na siya, you can now have the first, no, appearance of unknown, o yung kilalang bacteria during this time, which is now your cyanobacteria. May mga sabi, Mami, hindi yan bacteria. It's a protist, no? Marami din tayong ganyan. So, let's have say na the first living entity, the cyanobacteria natin, which is photosynthetic in nature and now produces oxygen. The cyanobacteria with conglomerate forming now your stromatolites, na these are extant sila, living pa rin silang mga fossils, stromatolites, which now, slowly, no, magkakalat ngayon siya sa ocean, releasing now intense oxygen, polluting the atmosphere with free oxygen. Ayan. And then, this could start now. Slowly and slowly, there is now progression of life on Earth. So, your Earth now, pero yung mga stromatolites na yan, yung mga early mga organisms natin ng mga prokaryotes, they were subjected to the changes in environmental conditions because Earth also experienced multiple times of ice age. Marami yan. So, may mga time na may tinatawag tayong warm age at may tinatawag tayong ice age. So, yung Earth natin, they oscillate warm age, ice age, warm age, ice age. So, actually, no, trivia lang mga anak. Ito yung sinasabi na yung global warming daw yan, yung mga climate changes na yan. It's actually daw dahil nag-oscillate yung age ng Earth in consonance o ang tawag dito, in combination, parang parallel siya sa oscillation ng buhay daw ng sun. Yun. Ito yung sinasabi na dahil umiinit na si sun, so yung age din, yung oscillation ng buhay din ni Earth ay nag-change daw. Nasa warm age tayo, kaya global warming. Pero darating daw ang time na mag-ice age na naman tayo. May mga ganitong theory, ha? Actually, meron akong naka-debate na Japanese, parang teacher din siya. Nakausap ko siya via the Skype noon, nung nagtuturo pa ako ng English language sa kanila. And he's good in English, ha? He's good na already in English, but he wants to talk lang. And then, nakita niya na science ang aking major, no? Nakikipag-debate siya sa akin about global warming. At sa kanya ko nalaman yung tinatawag nating oscillations of the life of the sun and oscillations of warm age and ice age of the earth. Nung tinignan ko yung mga study ng mga Japanese on these oscillations, medyo sinasabi nila on the part na hindi naman totally fault ng tao ang global warming and ice age, ang global warming and climate change. It's actually part of the life of the planet Earth and part of the life of our sun. Nai-intensify lang daw because of the pollutions given by the tayo, mga tao, yung living within the Earth. So, pwede siguro yung debate siya, pwede hindi. Okay, back in time, balik tayo sa primitive one. So, yung mga nabuo nating mga monomers, polymers, organic or biomolecules, yung ating mga cyanobacteria, some of the prokaryotes, yung mga bacteria natin on the primitive Earth now, na-subject sila ng oscillations ng warm age, ice age, warm age, ice age, which could consequently causes changes again on the makeup of the living ancestors natin. But what is for sure is that some of the prokaryotes, no, survived the snowball earth, yung changing ice ages natin, and they evolve into a more complex type, such as having endosymbiotic systems living together inside the cell. Remember, no, meron tayong mga cell membrane noon, so nagkakaroon ngayon ng endosymbionts yung nasa loob. Ano tong mga to? Pupuntahan natin ang endosymbiotic theory. Dito, it is evidence supports the idea that eukaryotic cells are actually the descendants of separate prokaryotic cells that join together in a symbiotic union. Ito yung sinasabi nila na, no, some of the eukaryotes or the eukaryotes that we are right now are actually because of endosymbiosis, engulfment of one prokaryote to another prokaryote and living together. So, actually, alam niyo naman na ito mga here, no? You have here your ancestral host cell, no? Nag-i-engulf siya ngayon ng aerobic bacterium, cyanobacterium, which now give rise to your modern cell right now. Ito yung mga cyanobacterium is your chloroplast, no? And then your aerobic bacterium is your mitochondria, which now leads to a more eukaryotic or itong modern cell na meron tayo. This kind of internal symbiosis is where one organism taking a permanent residence within another and evolving together in a single lineage. So, kapag one prokaryote engulfs your mitochondria, this will now mag-evolve sila as a single lineage, as one na, which now leads to your heterotrophic organisms, or mushroom and animals. But if this one now, this prokaryote with engulf, yung nag-change na siya, no? Na may mitochondria siya, nag-evolve na siya as one, engulf another prokaryote and live again together symbiotically and then evolve together as a single lineage. Yan naman ngayon, this one now gives rise or becomes now the ancestor of your autotrophic organisms, such as your algae protists and your plants in the symbiotic theory. So in a nutshell, there are two independent bacteria or prokaryotes, one engulf the other and live inside excuse me, symbiotically, and then they provide each other to the point that they evolve in as one entity na lang, and then they are now being passed from generation to generations. Ito yung kanina dun sa artistic. This prokaryote is being engulfed by a larger prokaryote. No? Actually, in the symbiotic theory was proven, no? It was proven accidentally by a Korean scientist, si Oppa Gangnam-style. Charis, no? Meron tayong scientist. Sorry, joke lang. No? This is by the microbiologist Kwang Jun. No? He was studying amoeba. So, amoeba are protists. No? When his amoeba communities were struck by an unexpected plague, meaning nagkaroon na parang, I don't know what causes him to have, nagkaroon siya ng mga bacterial infection. Kung hinandle niya siguro to properly or nagkaroon siya ng mishandle niya ang amoeba niya sa lab, nagkaroon ngayon ng introduction of your mga bacteria. And this bacteria now entered, no, pumasok siya, in-infect niya yung mga amoeba, no, na-infect yan, nakapasok siya, at to the point that almost 90%, no, mataas yung percentage ng amoeba niya namatay. However, na-observe ni Kwang Jun that some of the amoeba that survived the plague, yung mga buhay na amoeba na natira, meron siyang bacteria sa loob. No? There was a bacteria within this amoeba. So, akala niya na wipe out yung total population ng amoeba niya. But then again, napansin niya, may mga surviving amoeba siya na merong bacteria within its body. And this actually replicated. So, nanganak pa siya. Ngayon, what Kwang Jun did is that nag-introduce siya ng medicine to kill the bacteria. So, ang gusto niyang gawin, gusto niyang i-revive itong amoeba niya and kill this plague para makuha niya ulit yung mga sampled amoeba niya kasi nga naman, ang hirap naman talaga mag-isolate. So, ang ginawa niya, nag-introduce siya ng medicine. Kaya lang, yung medicine na yun, para patayin yung bacteria itself. Kasi pang bacteria lang yun eh. Kaya lang, what he observed is that, nung namatay yung mga bacteria within the protist o yung sa amoeba, pati yung amoeba niya namatay. No? So, literally thousands of tiny invaders, no, squeeze inside the amoeba cell, causing the cell to become dangerously sick. Only few amoeba survive. So, yun yung sinasabi ko sa inyo. So, what he did, nag-introduce niya siya ng bacteria, nag-introduce siya ng gamot, no, antibiotics, this one, no, nag-introduce siya ng antibiotics to kill the bacteria inside. Pero what happened is that, namatay nga yung bacteria inside, but even the host amoeba died also. So, the amoeba could no longer live without their former attackers. So, what happened is that their former attackers now became symbionts of this amoeba. So, dito, in this theory, dito sa nangyari kay Kwang Jun, he discovered now, or in his accidental experiment, proved the endosymbiotic theory. So there's a possibility, that tayong mga eukaryotes right now are really products of endosymbiotic processes of our ancestors. Kumbaga, yung endosymbiosis na nangyari noon sa mga ancestors natin ng mga prokaryotes or eukaryotes and prokaryotes now causes us to have what we have and what we are right now. So this now, so ito na, at long last, magkakaroon na ngayon ng mga eukaryotes because of this endosymbiotic theory. So this eukaryotes now tayo. Of course, may mga prokaryotes pa po tayo right now. No? We have still the bacteria, and we have still your archaeobacteria. No? May mga, yung ating domains pa, no, ng mga prokaryotes. Meron pa naman. But we also have now the domain of eukarya because of this process. So, because of that, ayan, may prokaryotes ka na, may eukaryotes ka na, there's now the start, no, of the entire evolution of life on our planet. Ngayon, mga anak, pwede na ngayon natin pag-usapan ang process ng evolution. Okay? So, I hope you learned something new with today's discussion. If you have any question, please write it down, and we will be meeting synchronously the next meeting to facilitate discussion on the previous videos that were uploaded. So thank you everyone. Have a good day. Do not forget to take down notes and to submit the notes to me again on our group chat. Thank you everyone. Have a great day. Bye.